in the reaction between barium chloride and silver nitrate, this is a double replacement reaction. You have barium chloride, silver nitrate, they react. Your anions trade spots, so instead of barium chloride, now you have barium nitrate. Instead of silver nitrate, now you have silver chloride. So you have your equation, it needs to be balanced. We have two chlorides here, only one there, so we need to make that 2. You have two nitrates here, so we need to make this 2. That gives you 2 silvers, 2 silvers, 2 nitrates, 2 nitrates, 2 chlorides, 2 chlorides, 1 barium, 1 barium. So this is balanced. So the question asks for the mass of barium chloride and the mass of silver nitrate that would be needed to produce 2 grams of your precipitate. So which one is the precipitate? Well, you look at your solubility rules. Barium chloride is a reactant, silver nitrate is a reactant, barium nitrate is a product, silver nitrate is a product. So these 2 products, one of these could be the precipitate. So which one's the precipitate? It's the one that's solid. To determine which one is solid, you use your solubility rules. So over here, nitrate, we know is aqueous because nitrates are all aqueous. Barium nitrate, nitrate, soluble. If it's soluble, that means it's aqueous. There are no exceptions. When you look at silver chloride, chlorides are also soluble, but there are exceptions. Silver is one of the exceptions. So since that's an exception, it's not soluble. Instead, it's insoluble, which means it's solid. If it's insoluble, the state of matter is solid. If it's soluble, the state of matter is aqueous. Insoluble, solid, soluble, aqueous. Since we're looking for 2 grams of our precipitate, silver chloride is the precipitate. You start every problem the same way. Start with what you know. So we're looking for 2 grams. We're producing 2 grams of silver chloride, and we are looking for the mass of barium chloride and the mass of silver nitrate. That means you're going to do this problem twice. Once solving for the mass of barium chloride, second time solving for the mass of silver nitrate. So in the first one, we're looking for barium chloride. We're given mass. We're looking for mass. Well, that makes this a mass-to-mass problem. Start at mass, go to 2, to 3, to 4, to end up at mass. Mass to mass. Mass of substance A, mass of substance B. You have to go from mass to moles A, then to moles B, and then to the mass of B. So A is what's given. B is what you're looking for. So in the first problem, we're going to solve for the mass of barium chloride. That would make barium chloride B. So when we follow our flow chart, you go from 1 to 2, and that first conversion factor is the molar mass of substance A. So we need to get the molar mass of silver chloride. So silver we're going to get the molar mass of silver chloride. When you look at the periodic table, you find silver. Here's silver. The molar mass of silver is 107.868. The mass of chlorine is 35.453. We have to add these two together to give you the molar mass. So it's just simply 107.868 plus 35.453. That gives you a molar mass of 143.321. So back to the conversion factor, it will be 1 mole of silver chloride over the molar mass of silver chloride. Okay. You look at our units here, we have grams of silver chloride and we have grams of silver chloride. They're the same. Grams of silver chloride over grams of silver chloride, so they simplify. Now, the next step in the conversion, your next conversion factor would be moles B over moles A. Moles B is barium chloride, moles A is silver chloride. So when you look at the balanced equation, we have 2 moles of silver chloride. We have 1 mole of barium chloride. So moles of silver chloride, that's moles silver chloride on top, moles of silver chloride on bottom, so they would reduce. Last step, we went from 1 to 2 to 3, now we need to go to 4. Your last conversion factor is molar mass of substance B, because when you look at it, substance A, silver chloride, silver chloride, silver chloride, it's all canceled out. There's no silver chloride left. We have officially converted from substance A to substance B. So we're going to get the molar mass of substance B. The molar mass of barium is 137.328. Chloride again is 35.453. There's 2 of them here. So 2 chlorides times the molar mass of chloride, which is 35.453. Add those 2 together. 137.328 plus 2 times 35.453. 208.234. So the molar mass of barium chloride is 208.234. That's grams of barium chloride over 1 mole of barium chloride. Moles of barium chloride cancels out, so then we need to punch it in the calculator. Two divided by 143.321. Again, since this 2 right here is in the denominator, we divide by 2. 208 is in the numerator. That gives you 1.45 grams. Of barium chloride. So there you go. That's how you get the mass of barium chloride. You do the same thing essentially to get the mass of your other reactant, which is silver nitrate. So we do the same process. Silver nitrate will be what we're looking for, so that's B. Silver chloride, again, is what's given, so that's A. We do the same thing, A to B. Same process. We're going from the mass of A to the mass of B, and we use every conversion factor along the way. It's all the same. First conversion factor doesn't change because silver chloride is still substance A. That doesn't change. Our mole-to-mole ratio will be different. You still have 2 moles of silver chloride because of this. How many moles of silver nitrate do we have? 2. And then the last step, we need to get the molar mass of B. So silver, we look at our periodic table and find silver, 107.868. We need to find the molar mass of nitrogen. .007, and then the mass of oxygen. There are 3 oxygens, 15.999. Three times 15.999. Plug it in. That gives you 169.872. So the conversion factor up here, once you've canceled all your units, so that's the molar mass. Now we're going to plug it in, just like before. Two grams divided by 143.321 times 2 divided by 2 times 169.872. Hit enter. That gives us 2.3 grams, 2.37 grams actually, 2.37 grams of silver nitrate. So 1.45, 2.37, that's how you solve that problem.